Hello and welcome to YourPedia. My name is Aman Sharma and I am your mentor for CSE at YourPedia. So today we'll be discussing a question from our NPTEL question bank series, and the question is from algorithms. You can find the question on page number 10. The question is question number 52. You have been given a recurrence relation. This is a recurrence relation that you have been given, and it is asking if you use the recursive tree method, then what will be the time complexity for this recursive relation. So the recursive relation that has been given to us is T of n is equal to T of n by 4 plus T of n by 2 plus n square. Now in this, whenever a Tn is divided into Tn by 2 and Tn by 4, the remainder is n square for each level. Like when you distribute Tn, the remainder is n square. If you distribute Tn by 4, the remainder will be n square by 4 square. So whatever you are distributing, the square power of that element will be present there. So let's try to do this using recursive tree method. First of all, initially there will be Tn and it will be divided into Tn by 4 and Tn by 2, and n will leave the remainder n square. Now for the second part, now whenever you divide a Tn, it divides into by 4 and by 2. So if you divide Tn by 4, it will be divided into by 4. So 4 into 4 is, by 4 will give you 16 and by 2 will give you 8. N by 4 into 4, n by 16, n by 4 into 2 is n by 8 divided by 2. You are dividing by 4 and dividing by 2 the original n element, and if the original is n by 4, you are dividing n by 4 and n by 4 by 2. Again, when you divide this, it will be divided by 4, so 8, and again 4 here. Now what about the remainders of this? Now when you divide T of n, the remainder is n square. When you divide T of n by 4, the remainder will be n square by 16 whole square of the 4 plus, and when you divide Tn by 2, the remainder will be n square by 4, which if you want to solve will give you 5n square by 16. Now for this level, for the first level the remainder is n square, for the second level the remainder is 5n square by 16. Now let's move to the next level. Now here you will get by 4 you will get 64 and by 2 you will get 32. For this by 4 you will get 32 and by 2 you will get 16. For this again by 4 you will get 32, by 2 you will get 16. For this you will get by 4 you will get 16 and by 2 you will get 8. Now what about the remainders for this? Now for this, for n by 16, if you divide T of n by 16 in the recurrence relation, the remainder will be n square by 16 square. For this it will be n square by 8 square. Again n square by 8 square for the third one, and for the fourth one it is n square by 4 square. And if you want to calculate it, it is n square by 256 plus n square by 64, n square by 64 plus n square by 16. Now if we solve this further, the LCM will be 256. This will be as such n square. This will be what? 4 n square plus 4n square plus 16 n square, and if you simplify this, it will become 25n square by 256. And if you want to simplify this further, you will get 5 by 16 whole square n square. Now if you try to look at the pattern, I can write this n square as 5 by 16 raised to power 0 n square. Now on the first level, the remainder is 5 by 16 raised to power 0 n square. On the second level, the remainder is 5 by 16 raised to power 1 n square. On the third level, the remainder is 5 by 16 raised to power 2 n square. So if you can see the pattern here, 5 by 16 raised to power 0, 5 by 16 raised to power 1, 5 by 16 raised to power 2, and so on. So on the fourth level, the remainder will be 5 by 16 raised to power 3 up to n square. So these are the remainders on each levels. Now if we can find out the number of levels in our tree, if we are able to find out the number of levels in our tree, we know this pattern, then we can find the total time complexity. Now let's try to find the total levels in this tree. Now the tree is being divided like this: n by 2, n by 8, n by 16, n by 8, n by 8, n by 4, n by 64, n by 32, n by 32, n by 16, n by 32, n by 16, n by 16, and n by 8. Now the table is being divided like this. Now if you look at this side of the table, every element is being divided by 4 when you move on to the next level. So when you are dividing by 4, this side will be completed first because you are dividing by a bigger number. In this, you are dividing by 4. So this table, let's assume this line stops here. This line will go a little bit longer. Why? Because in this we are dividing by 2. So this will be the longer path. So if you want to find out the complexity in order or big O, in terms of big O, then you need to find out the upper limit. And if you need to find out the upper limit, you need to consider the larger number of levels. So let's try to find out. If we take this side, what will be the number of levels? So at first level we have n, at second level we have n by 2, n by 4, n by 8, and you can write it as n by 2 raised to power 0, n by 2 raised to power 1, n by 2 raised to power 2, n by 2 raised to power 3, and when you move down the line, you will reach n by 2 raised to power k, something like that, and the table, or you can say the levels, will stop when n by 2 raised to power k will be equal to 1. That means that you have t of 1, that you have made n by 2 raised to power k equal to 1. So this will stop when n by 2 raised to power k will be equal to 1. So this means n will be when n will be equal to 2 raised to power k, you will have t of 1. Now what is k? For first level 2 raised to power 1, for second level 2 raised to power 2, for third level 2 raised to power 3, for kth level we have 2 raised to power k. So what is k? K is the number of levels. So if you can find k in this, k will be equal to, taking log both sides, log 2n. So the number of levels in this tree will be, maximum number of levels that are possible in this tree will be log 2n. Now at each level we have the remainder and we have the number of levels. Now we can find out the total time complexity for this. So at first level we have 5 by 16, 0, n square. Then after that 5 by 16, n square, 5 by 16 raised to power 2 n square, and so on up to 5 by 16, and the number of levels are log n, log 2 base n, n square. And if I take n square common, it is 5 by 16 raised to power 0, up to 5 by 16 log n. Now you can try to solve this, or there is a theorem that says if you are finding the sum of a decreasing GP. Now 5 by 16 is less than 1, so it is a decreasing GP. The values are decreasing when you are going down the GP. 5 by 16 is 1, 5 by 16 raised to power 0 is 1, 5 by 16 raised to power 1 is less than 1, 5 by 16 raised to power 2 will be less than 5 by 16 raised to power 1. So the values are decreasing here, so it is a decreasing GP, and time complexity for decreasing GP is always order of 1. So the answer will be n square into order of 1. So the time complexity that we need to find for our question is order of 1 into n square is order of n square. So the correct option will be order of n square. And if you want to find how this sum of GP comes to be order of 1, so let's try. Now for sum of GP the formula is a raised to power 1 minus r raised to power n by 1 minus r. Now a is 1 because the first term in the GP is 5 by 16 raised to power 0, so a is 1 into 1 minus 5 by 16 log n divide by 1 minus 5 by 16. If you solve it further, it will give you 16 log n minus 5 log n divided by 16 log n. We are taking the LCM here, and to solve this 16 minus 5 by 16, which is equal to 11 by 16. So it will give 11 into 16. Now the base for the log is 2, and there is a property that you can change this 16 and interchange this 16 and n. So if you do this, it is n log 2 base 16 minus n log 2 base 5 n log 2 base 16 into 11 by 16 by 11. Now what n raised to power log 2 base 16 is? Now log 2 base 16 is 4, so it is n raised to power 4 minus log 2 base 5 will come out to be around 2.12, 2.2 like that. So you can just write 2.12 something, divide by again n raised to power 4 into 16 by 11. Now when you are counting asymptotically, we are not going for the exact values, we are counting asymptotically. So asymptotically n square minus n4 minus n raised to power 4 minus n raised to power 2.21 will be order of n4 asymptotically, and divided by n4, which is also order of n4, n raised to power 4, which will be equal to order of 1, and 16 by 11 is a constant, so it will again remain order of 1. So sum of decreasing GP is always order of 1. So if you look here, the sum of decreasing GP is order of 1. We have n square in the multiple of this, so n square into order of 1 will give you order of n square. So the time complexity for this tree will be order of n square. So the correct option will be n square. So I hope you understood this concept. So keep watching for more interesting questions like this. Thank you and keep watching.